Ready? Hi, good afternoon. Welcome. My name is Kimberly Blackrincan. I am the director here at the Ignite Hub, and I'm here with my esteemed colleagues. We have Watney Sai, our lab coordinator, and Eduardo Novoa, who is our technical training and development coordinator. We are the team that coordinates the Ignite Hub here. If this is your first time here, welcome. This is a brand new space in Montgomery County. We are meant to be an asset for the entire community, from kindergarten to 12th grade, college students, career changers, and even our 55 plus community members who would like to learn their iPad. So we try to offer services for everybody here. Today is our Future of Tech Lunch and Learn. This is part of our guest speaker series. It was one of our first programs that started when the hub opened in May 2022. So we are, as one of our guests said, our third season of our guest speaker series. This guest speaker series and the Fireside Chat Career Series that happens on Monday evenings in the first of the month is sponsored by Verizon. So each event has a meal. So today we have lunch, and during the week, our Fireside Chat, we have dinner. So I'd like to thank Verizon for their sponsorship of this guest speaker series, that we're able to not only share knowledge, but also share a meal together, which is really important in building community. So to get us started, we have a very special guest here today for our Future of Tech Lunch and Learn. It's one of our own here at Montgomery College, Mr. Norman Singer, and he's going to talk to us about 3D printing technology. So this particular guest speaker series is about cutting edge technology. And what is it? Why is it important? And, sometimes there are buzzwords and things that go with it. So we want to make sure we're sharing with the community what's really important about 3D printing. So I'm going to read a little bit about his biography. So Norman Singer has over 30 years experience in the IT and computer programming industry, specializing in interface design. Having worked for both large corporations and startups, Norman combined his interest in cooking with his experience in design and 3D printing to design his revolutionary chef's knife. While preparing food for a large family dinner that his family hosted, Norman suffered from a very large blister and other repetitive motion injuries despite using a $200 name brand knife. His insights into design resulted in 13 US patents for the chef's knife, 2 utility patents, 11 design patents. He uses 3D printing for rapid prototyping as well as driving down development costs. It's my honor to welcome Norman. Not only is he works in our cybersecurity lab up on the Germantown campus, what I'm really excited about is this is what I love about working here at the college and the guest speakers that we have is that we all have interests outside of work, right? So this is Norman's opportunity to share with us something he does outside of his professional role here at the college, and I'm glad that we're able to celebrate that. So I'm going to pass it over to you, Norm, and you're on.
I'm Norman Singer. We're going to talk about 3D printing and the creative process of how I integrated the 3D printing into redesigning the chef's knife. So first off, let's see. No, there we go. Okay, so first off, a little about what we're going to be talking about. So what is 3D printing? And then how do we make a chef's knife? What's the problem? We're going to go through the creative process, how we made the chef's knife, the problem, the requirements, and then the results. Okay, so a bit about myself. I was in the U.S. Army in the Medical Corps. I was at the Walter Reed Army Institute of Research. A part of what I did there involved studying repetitive motion injuries, and I also did some work in hand physiology. After I left the Army, I finished up a degree in computer science. After that, I was in the police department, and I was on the SWAT team as a sniper. The interesting thing about snipers is that as a group, they like to design their own tools. every little edge that you can give yourself makes a difference between coming home and not. So as a group, it was a unique opportunity to work with a hands-on bunch of people that were examining things and asking the fundamental question, how can I improve this? And as I said, you know, you bet your life on it. You have a lot at stake. My wife likes to cook. I'm the sous chef. I get the chop. Also, I like to build things in the corner. We did outdoor patio furniture with the kids. If you look in the back of the picture, you can see that's the before, that was packing crates. And in front is the Adirondack chairs that we built. And as I said, my kids got used to it. They're a good bunch. And with regards to technical prowess and that, I have 13 patents in knives and a few other patents in computers, different interfaces and protocols. On the left is my daughter Ariella. She picked up my skydiving. I was airborne when I was in the Army for part of the time. She picked up my like of skydiving. My son Nathaniel is on the sander. He in his off time is a EMT. He comes back and says, I'm getting close to the number of babies you delivered. And my daughter Tamar is a cybersecurity expert. She's also a better shot than I am. But she says she has a good teacher. These are two of the utility patents that I have for the knife. The one on the left is a utility patent for the blade. So we redesigned the blade and broke the spine so that it accommodates the hand. And the one on the right is the same approach, but we redesigned the handle so it goes into the area that's traditionally into the blade. And again, it accommodates the hand, but one does it from the handle and one does it from the blade. So these are two conceptual patents that change the way knives are designed. So what is 3D printing? So the purpose is to give you guys an overview of what we're doing with 3D printing, how does it work, and then how did I apply it for the chef's knife. So first off, there's two types of 3D printing. You have additive 3D printing and subtractive. Okay, additive building, you start with a blank sheet and you build up. Subtractive is you start with a block and you work down to your final shape. So 3D printing is first started in 1986 by Charles Hull. He also invented the STL format, which is, when you're in 3D printing, you'll know what it is, but that's what you save all your shapes as. And that's the standard that we use. What we don't recognize also is that HP came out with something similar for 3D printing with their inkjet. You see it mostly that it squirts ink on paper and they use it for their printers and they've been very successful with that. But initially when it came out, they were using it in their biomedical space to do time release pills. You could lay down very exacting layers of medicine and your pills, you have incredible control on time release with when your pills are being formed. So they came up with a different way of doing that. They decided that the printer market was larger and that's what they're known for. But it's interesting that the inkjet is also used in 3D printing. Okay, so what is the common 3D printing that we use? If you imagine you have a glue gun, okay? You have your stick of glue in the back, it goes through the heat, and then it goes through a nozzle. So you lay down a strip, okay? That's what comes out of the 3D printer. Now, if we combine it with a robot so that we can put that glue exactly where we want it, and we take it with a superfine nozzle so that it's only the width of a human hair, and we add like 50 yards of plastic in the back, then we get an idea of what 3D printing is. And it's basically you're just taking a glue gun and you're drawing shapes. Okay, but we're using a robot to do that. And we get some pretty interesting designs out of it. One of the things that you do is that if you take a close look, we'll hand out some stuff. You can take a look at some of the interesting shapes that you could build with it. One of the things that if you look at it very closely, you'll see that in between the different layers, you'll see that there's a slight gap. It does not fill it 100%, but like I said, it's usually used for prototyping, so there's no need to do that. But you can come out with, as you saw, with rather complex shapes. The level of detail for mine is thickness is important, not the level of detail that you come out with these. The second, another way of doing this also with an additive process is metal. You can do 3D printing with metal. Okay, so what it happens is you take the metal, it's a very fine powder. It kind of looks like what you'd use in a copy machine. And you aim 2 lasers at it. And when they meet at the middle, it fuses the metal, it hardens it, it melts it into something hard. And that's how you do the shape. And you go layer by layer, the same way that you're doing it with the plastic, but you're doing with metal going through the through the powder. Okay, and again, you're controlling the laser with a robot arm, so you're very precise. You have the precision that you want to get the object that you desire. Whoops. Oh, whoa. So here we have what it actually looks like. You have the laser on the left, and on the right, you see the pile of powder that's being formed into the base layer of shapes. Okay, it's the same idea as the plastic, but different. And you can do this with stainless steel. You can do this with titanium, nickel, silver, gold. You have a lot of flexibility with with the materials. Okay, so now to the second type of 3D printing is subtractive. So if we start with a block of aluminum or some other solid material, sometimes they use styrofoam, sometimes they use wood. Okay, and we take a Dremel tool. You know, it's just like a drill with a bit that carves out pieces of metal, and we control it. We can make a shape out of it. Okay, now the best way to think about this practically, that we have a common example, is think of a block of marble that a sculptor has. And you take the little chisel, and you knock it out, and then you have Michelangelo's David, right? Or Mount Rushmore. And it's the same thing. You have a solid block and you remove it. Okay, here we're just doing it with the Dremel tool. We're doing it fine. And we're having a robot arm doing it so that if you can imagine the object, the robot can make it for you, and you don't have to be a great artist in the terms of being able to envision it and have the coordination to be able to do it. So it brings this ability to the more regular person. You still have to be able to envision it, but you don't have the constraints of having to be able to do this yourself. Here's an example. On the left, you have an idea of what these machines look like. It looks a lot like the additive 3D printer because you have the robot arm that's controlling this. It's the same thing. A robot is a robot when it comes to controlling it. On the right, you see you can get very complex shapes. And you have what's in essence is a drill bit, or a bit that when it spins, it carves. This could also be a router if people are into woodworking, that it's the same thing. But it's something that's controlled by a robot arm, and it gives you a very precise control, and it goes layer by layer. That's the other point. They both work layer by layer. It's not like it does all one part and then starts from the beginning on another. Just goes one step at a time. Okay, so how do we tell the printer what to print? Okay. So we have different 3D printing programs. AutoCAD is a popular one. SolidWorks is another one that's very popular. And there's about 20 or 30 others. Some of them are free, or some of them are open source, and they do that. You draw the shape that you want. You do it in 3 sides. Here is the top view when you have it very exact. You have to do the side and the right. So sometimes you have to do the left, sometimes you have to do the bottom, depending on how complex what you're going on, what's going on and what you're designing. So you see, you have the different views. So I guess if it's an object, you have to have at least 6 views. Depending, if it's complex enough, you have to have at least 6 views. With me, what did I have? I think I had 3, because mine is not, I don't have that level of detail. Okay? So you draw it in, it has the exact measurements, it shows the different views, and you know what the object is. And the magic is that it puts it all together and it can imagine what's going on. Okay? Another thing that's very popular in the 3D space now is 3D scanners. Say I have an object, it's already been made, and I want to tweak it, and I want to know how, if I make this little change, is it going to do it? And the object was made traditionally, whatever that means. But I have an example in front of me, and I'd like to get it into the 3D printer. I'd like to make it in plastic, and I'd like to make the changes that I'd like to make. Okay. A fast way of getting it modeled is a 3D scanner. And that's what we have on the board. So what happens is that it has a laser, and it shoots it line by line, and it scans it with the laser. The table turns it around. Generally, it takes about 100 pictures, slowly as it goes around. The white dots are reference points that are designed to attract the laser so that it knows the position of the dot, it knows how far it went, it knows exactly, it's how it calibrates itself and how it knows what the object is supposed to be looking at. And then it takes these 100 pictures and puts it together and creates the object. You know, there's some real software magic behind the scenes. I'm just giving you the big picture, but like really behind it, there's some real genius that puts everything together. So I don't want to make it sound like it's oversimplified, but that's basically what's going on. It's just laser. Now you also use these type of lasers with self-driving cars. So also it tells the distance and what's going on, and it does the mapping of the environment around it. So the same thing, another application is self-driving cars. But in 3D scanning that we have these, and they are coming down in price. I think that you could get a reasonable one in the $300 to $500 range. So it's becoming affordable if you're serious into this as a hobby. And then, of course, the industrial ones are in the several thousands or tens of thousands of dollars for something really, really high end. But also, if you think about it, you can get it as a service. You know, oh, I just need this. Pay whoever $100 for a scan, and then have a very detailed scan of what your object is, and you only need it once or twice, so it's not that expensive, relatively speaking. So we can 3D scan it. Okay, when you 3D scan it, when it does with these pictures, it takes layers and makes it into tiles. So this race car is a nice example of what it does. It takes it, it makes it into tiles, and these tiles are shaped into what your end object is. And this is a nice example of it. But that's what it does. When these things came out, the popular thing that people did was they would do 3D models of their head. I don't have any examples of that, but it's this. But you'd be using the same modeling. You'd be using these tiles that were put over and over, and you can get the fine detail that you could have. That you could do somebody's head, hair, was the whole. It looks good. I mean, you saw the examples that we handed out. You can imagine that that's what you wanted to do, you can come out with something that looks good. Okay, so let's go to the application. So what I want to do is take you through the creative process of how I went through to redesign the knife. Where did the idea come from, and how did we and what's the path that I took? How do we use the 3D and how do we apply 3D printing, and why is it important? Okay, so my wife likes to cook. Sometimes we have over 80 people for some of the dinner parties that she cooks for. I do the prep work. Okay, I get to cut the food. That's my job. I like it. Whatever. It's a fair division of labor. She's a good cook. I'm a good cutter. It works well. And my kids also became foodies as a result of that. Okay, so what's the problem? Okay, one of the things, if you talk to people in the cooking space, is you have a chef's blister or a callus on your index finger. Okay, you'll also have repetitive motion injuries in your wrist. Okay, those are the two things. You either have a blister if you're new, or you have a callus if you're old, and you have repetitive motion injuries in your wrist. I started with a Wusthof Le Cordon Bleu. It's about 100, well, it was about $170. Sometimes they're on sale, whatever. You're not going to get them cheap. It's a good knife. I like it. I still have it. But I think, given my background and all of that, it can be better. Okay? But this is the problem. So what's the cause? Okay, so I explain the cause as being it's poor ergonomics. If you look at chef's knives, it doesn't really matter which company you go with, they all look the same. And the differences that they talk about is different steel. Sometimes the handle's a little optimized for this or that, but they're generally the same. So I think, and there are a lot of advantages to it. It's evolved over 200 years, and it's come to something that's good. But I view that there's a problem. Okay, the problem I see it from the use of interfaces is that you want to grip the blade. So what we do in the, let's see, here we go. What we do in the cooking space is you have the pinch grip, or in German, it's a Dreifingergrippen. It just means that you're gripping the blade with the last 3 fingers, and that you're pinching the blade itself with 2 fingers. So what's the problem? The problem is the skin on metal. Okay, the problem is skin on metal, and you know who wins every time. Okay, so but why do we do it? Okay, when we do it, if you look at it, if I'm gripping the blade up here, in essence, I'm using a shorter knife. This is an 8-inch blade. I'm gripping in front. Now it's a 6-inch knife. So in terms of having to raise the knife, I don't have to raise it as high. That means that I can cut faster and have more precision. Okay, but it's at the expense of my finger. So that's why it's popular. Okay. I also show an example with a paring knife that I didn't happen to have with me. That people, when you're cutting with a paring knife, classically, you always have your finger behind it. You get more power, because instead of putting power on the handle, we can put power into the blade, and you have more power when you're cutting. Okay, but you have the blade pushing back on your finger. Okay, so, and again, metal versus skin. Okay, it's a no-brainer who wins. Okay. The other reason that people do it is you see this on the cooking shows, you know, and it looks cool. So everybody has to do it because, you know, if Chef Ramsay is going to do it, or all the others that you see on the Food Network, you know, then I got to do it too. Okay. So now, why do we have the problem? So I view it like this: we have a case of institutional blindness. Okay, whenever you take a knife out, the classic thing of the swordsmith is always going like this, right? You know what I'm doing? You're always checking it. So what do we have? We have a straight spine and we have symmetry. Okay, that's a classic knife. Straight knife and symmetry. Okay? And I'm saying that that causes institutional blindness because that's what you're looking for. That's what we're trained for. You know, when you're looking, how am I going to make it? How am I going to make it better? Whatever you're doing to make it better, it's still going to be straight. So that's one problem. The other problem is that the advantages of gripping the blade are real advantages. You know, if I told you I can cut your cooking time or your prep time by 30%, you're all for it. You know, if you're doing this at home for your wife and yourself, or you know, for your spouse, 2 people, 4 people, 5 people, even if you have a large family, 10 people, fine, do whatever you want. Go into cooking for 20 plus, 50, 100 or whatever. 30% is a huge amount of time. Okay, so the temptation to do it is there because the rewards are real. So that's the problem. We have an institutional blindness and we have a real need for it. Okay, so my question comes to basically to this. How do we make a knife that accommodates our hand versus make our hand accommodate the knife? Okay, you have to flip the question on its head and then you start to look at the solution. Okay, so I want to make the knife that accommodates my hand. I'm working from a blank slate. And what I'm going to show you how I did this, when you see blank, we're talking completely blank. Okay, so also when we talk about an ergonomic knife, what parameters do we want? Okay, so we said we want to avoid metal on skin because metal always wins. Okay, it has to accommodate the hand, right? Even with metal, okay, it has to be something that's called ergonomically neutral. Okay, if we have some of these knives that make you hold the knife in one position that you can't adjust your hand, then you get the wrist pain. Okay, so you have that problem that you have to be able to make small adjustments in your hand and how you grip the knife so that you use more of your body and more of your arm. If you are very limited to what you do, it's going to hurt. It's going to hurt. And in an extreme case, because you're wearing out cartilage in just one exact spot, you'll have problems. Okay, so we're trying to avoid that. Okay, so there's 3 popular knives. The one on the left is by a master bladesmith by the name of Ken Onion. This was his design. There's one by Boker. That's a very famous German brand. They chopped out the top, but you're still on the metal. The knife on the right is by a company called Ergo. Again, it holds your hand in one spot. There's no adjustment. So you don't have the ergonomically neutral, or you're still in contact with the metal. But I'm just saying that this is a problem that other people noticed also. So I'm saying, so what's a possibility? Okay, so these are several knives that I've done and have patents for. I did it in the beginning from CNC. We have the blade here accommodates the finger for a righty. The paring knife, the blade accommodates your hand so that you can, when you reach in to get that extra bit of power by directing the force to the blade, not from the side, that it cradles your finger as opposed to push back. Also slicing, a lot of people like to aim when you slice and you hold your finger along the spine of the blade. So now you've just transferred the problem to your knuckle and to your fingertip. And we've accommodated your hand by reducing the angle of by reducing the angle of your finger and accommodating your index finger on the spine of the blade. So those are the 3 knives that I've designed, and that's how you do it. But that's CNC milling, and the problem with CNC milling is that it's expensive. Not as expensive as actually having to do it by hand, but not cheap. Okay, so how does the design evolve? Okay, so when I say I worked with the blank slate, I worked with clay initially. So on the upper left-hand corner, you see that I made out of plastic. I have a rough cutout of a knife, of a chef's knife. I cut out the problematic area and I filled it in with clay because I didn't know what the answer was going to be. And I figured that if I have a rough idea of the knife, because I want the edge and I want the cutting ability and I want all the benefits that I get from it, but how is it going to accommodate my hand? So let me make it out of clay and I'll get a good idea of how to start. And clay is a good blank material. So on the right-hand upper level, you have with the clay, and that's what it looked like. That it has this dimple that goes into the other side. I went to a machine shop. I had several of these knives made. It cost about $1,400 for all of them. Arm and a leg. Went to Europe with them. Went to several startup competitions to talk about it. And that was that idea. Then I decided that if making it out of metal was too expensive, and how about redesigning the blade, the handle itself, so that I can have a cheaper version. You know, you have a high-end version of a knife. I don't have that's you know your $150 plus knife. You know your Wusthof, your Henkel's, Sean, if you're into the Japanese knives, or they make excellent knives. But you also have like the Victorinox makes cheaper knives for the kitchen. How can I make something to compete in the cheaper space also? So that if I have it, so that I can have a whole line of knives at the higher end and the lower end, so that because in a kitchen, in an industrial kitchen, you're not going to give everybody a $150 knife. You're going to give them the cheapest knife that works, so that you can get the job done. Because they get broken, they get thrown out, they get whatever. You're not going to do it with a $200 knife. You're going to do it with generally it's a $20 to a $40 knife. So how can I enter that market also? So the answer to that was by changing the handle. So the first time I did it, I tried to do it out of wood. I'm reasonably good with wood. I tried to do it. I mean, the idea came out, but it didn't feel good. I didn't get the precision that I needed. So on the lower left-hand corner, I managed to 3D print it, and I cut it out of plastic, and I have the handle that accommodates it. The second in the lower left-hand corner is that design was good, but not good enough. It was good in that it took care of the problems, but it didn't allow for micro adjustments. It locked the hand into one position. And the second one, where the dimple is more broad, took care of that problem. Well, took care of several problems. First off, it took care of the problem that you can move your hand. You have room for adjustment. And also, you can accommodate a larger variety of hands. You don't have to say this is, your small, medium, large. No, everybody gets the same knife. Okay, so it took care of two problems. And on the bottom right-hand side is what the final idea looks like. Here we could pass around. Pass around some knives. You can see what it looks like. And then we'll talk about a little bit more how we 3D printed it. These are sharp, so don't take the guards off. I keep finding that out as I play with it, that you cut your hands. Okay, so how do we make a knife with 3D printing? So we'll take a look. This is what it looks like as it's coming out of the machine. Okay, this is the base layer. This is the base layer. Okay, here we can show you. Now, also we have going around that we have the blade, okay, so first we make our handle. Now we have to get the blade. Okay, so what I did was I took a regular knife, I cut off the handle, I cut off the dimple. I'm working in my kitchen, not really thinking, everything's all well and good. My daughter's taking pictures, and then the tablecloth catches on fire. We don't have any dramatic pictures of that because she put the camera down and decided to take care of the fire. Now, at the time, that seemed to be the right idea, but nowadays, I think that maybe some of those pictures would have been fun to have. But at the time, yeah, at the time, she probably had her priorities right. That's my youngest, Tamar, who was taking the pictures, and we got moved to the living room. And she does it also. She's an incredible, well, she's incredible. When I did this second set of hands, she's there. So let's take a look at how this happens. How do we do it? You take a look on the upper right, you have to take a look closely, but first you mark out the area that you want to cut. And it's with a Sharpie, you know, you just use a permanent magic marker and you cut it, mark out what you want to do. Then I cut vertical lines into the knife, into the blade. Then I scoop out those things. Usually I take a pair of pliers and I break them off, and then I polish it out with the angle grinder. You cut off the handle. You just use the angle grinder and go down the spine and down the other way, and you get the handle off. Then you have the knife that's ready for my adjustments. That way, a knife like this, a reasonably good one, is about $20. If I 3D printed, it costs pennies, but then you have to buy the 3D printer. If I go to the 3D printer service, it costs about $10. Fine. Epoxy, whatever. You can do like 5 knives for $10. And that's how the cost is about, what did we say? The cost about $35 a knife. Not going to put you out of business when you're trying to invent something. It's in the range of affordable or doable, at least. It adds up because you keep doing changes and this and that, it adds up. But it's in the range of doable. And then you take a 2-part epoxy. I'm not going to pass this around because it makes a mess. JB Weld seems to work well. It doesn't need oxygen to dry. You mix the two, you smear it up, you clamp it like we have in the lower one, but that's the wood one. I didn't have pictures of the other one drying. You let it dry overnight, and you have a you have a knife the next morning. It takes whatever 10 hours to dry or so. It takes another 2 hours to harvest the blade, prepare the blade, cut off the handle, and get the dimple in. So 12 hours, but you're not working 12 hours, and you have it. The turnaround time for taking the knife to a CNC milling place and have a professional shop actually do it is 2 to 3 weeks. So I can try out new designs overnight versus 2 or 3 weeks. So you also have a time advantage. That helps a lot. Okay, so like I said, each knife costs, I said $50. I think it's probably closer to $35 to $40. Custom fabrication is about $1,500 for setting up everything and doing it. Speed, it takes a few hours it takes about 4 hours to print the handle. Didn't do that. That's about because it's doing it a hair at a time. So you can take a look at it, and it's doing it a hair at a time. So it takes about 4 hours to print. Think about an hour or so to get the metal, to get an existing knife prepared so that it can accept my 3D printed handle. 12 hours for epoxy, and that's versus 2 to 3 weeks from going it out. Okay. The big advantage is that you can make small changes. Small changes on a knife are very important. You can make small changes and get the exact model that you want. When you're doing rapid prototyping and you're trying to present to investors, the closer that you have to the final product, the better off you are. Nobody wants to know about your concept. If they can imagine what you bring to them sitting on a store shelf, you are much better off than if you can't. Nobody wants to be part of your imagination. They want to have a final fixed product that works. They don't want to use their imagination. Okay, you take a look at the knives that I've been passing around that I've made do look like something that you could find on the store shelf. At least 95%, 97% of the way their store might use different materials, but you're not using much imagination to see it, maybe just the packaging. So that's the difference. It brings it up to that level. The finished knives, I have two handles that I worked on. In addition to the traditional Western handle, I also found in my explorations that the Chinese use the cleaver not as a heavy-duty battle axe kind of chop through bones, but they use it as a chef's knife. And they grip it with the 3-finger grip, and they chop the way that we do. The way that we do. The way that's actually the way that we see in the United States, the way most European cooks cook. And but the Oriental handle is a octagonal handle. So I tried it for the chopping, and I also applied it to the chef's knife, that you have a nice fusion between European and Asian knives for a unique design that also people enjoy, that works with the ergonomic principles that we had. So this is the new design that I came out with. The one that I had for the cleaver, I misaligned the handle when I glued it, and I haven't redone it. But the idea came from the fact that the Chinese cleaver is used like very much like the chef's knife, even down to the grip, which was like incredible. And that's it. Are there any questions? Yes.
I have a bunch of questions, but the most important one is, well, your wife cooks for 80+ people, right?
Yes.
So what do I have to do to get on that list of?
You have to be her friend and be in Beit Shemesh.
Okay. Okay. Metal 3D printing.
Yes.
I have seen the plastic one, for example, at the American Library in DC. They have 3D printers. But this metal one, where can I see that?
You have to see if there are shops that do it. There is a place in California that if you mail them the STL file, they'll do it for you. The turnaround time is usually about a week.
No, I don't want to.
Oh, actually,
I just want to see it out of curiosity. Go somewhere, spend like an hour.
you'd have to see, there are places, if you buy a good 3D printer for plastic, it's gonna cost you about $500. A metal one is gonna cost you a few $1,000s.
Okay.
There are, like, there used to be copy shops or printers, places like Kinko's. There are 3D printing places that do the same thing. So you Google it and see who in the area does it. I think the University of Maryland has something
Okay.
where they do it, and you can see it. But if you're just curious, I mean, you're not gonna see much. You see a big device about half the size of the table, put it in the powder, and it's
Okay.
with a laser. They're mostly industrial in use.
Yeah. My other question is related to institutional blindness. So have you had conversations with some chefs? Were they complaining as well? But nobody was interested in paying attention to this issue?
Well, it's not that nobody's paying attention, it's looked at as a rite of passage. It's a badge of honor. You know, I'm real. You know, I paid my dues, I'm real. It's like a form of hazing. So that's not an issue, but also if you talk to chefs, or you talk to anybody that works in the kitchen, they'll say yes. But, you know, that's it. You know, the bladesmith looks for a certain design and everybody's expecting certain parameters. So I joke that, you know, the two signs of a quality knife are symmetry and straight spine. And I broke the spine and my knife's very symmetric.
So if this is a badge of honor, would they actually buy a knife that gets rid of that?
I've taken it to people that cut, and yes, the answer is yes. It might, you know, when you have a choice, people are interested in it. I've gone to people that actually do the chopping, and people have offered me $100 for the prototype. And that knife would go for about, when it hits the market, that would go for $30. So chefs, butchers, are interested in it because it is a much more comfortable knife. And, you know, comfort beats badge of honor all the time. Yes.
So what's the obstacle that you've been faced with marketing this knife?
The big one that I've had is I've tried to go the route of going to established manufacturers and have and licensing it. And it looks different. You think that looks different is an advantage, but nobody who, like the big guys, wants to be the front. I'm looking at a Portuguese knife manufacturer, tier 2, that's looking at it. The third option is because we have the handle and the adaptation, but we don't have the knife on there. Because the basic knife blade can be made on a traditional, the low end knife can be made on a traditional blade machine with the addition of the dimple cut out of it, which isn't a big deal for them. We're looking at going to a tier 2 and starting at the lower end. And then the big obstacle would be, how do you get like a celebrity chef to use it? Because you'd be surprised what happens, you know, one YouTube chef uses it and.
So let me ask you this, that knife you showed me there, the one with the dimple, is that the same one you passed out already?
It's the same, this is the cleaver this is the Chinese cleaver that I was telling you about.
Right.
It's the same handle, it's the same idea.
So the question is, how did you figure out where to make that dimple without compromising the strength of the blade?
Trial and error. First off, I knew where I had to make the dimple because I grabbed the knife, I inked up my hand when I grabbed the knife. So I got an idea of what area that I was putting it in.
I see.
The second thing is we're not cutting anything that's super hard. Most vegetables are not that hard.
Right.
Even if you're cutting meat, you're not cutting super hard. You can't, I wouldn't use this to cut through bone. But then you can chip the blade before you broke the handle. So, you know, in terms of the knife not being designed for it, it's not, you know, it's not a cleaver.
So
Take a cleaver, use it the way it's supposed to be used and go through it. But for regular stuff, you don't have that issue.
the other question is, so I know you have the dimple on one side, for the production where you have it on both sides, the curve.
What we found, this is a lefty knife. What we found was that it's, here you have the variety knife. We found that the dimple is very nice for the thumb.
For the thumb? Okay,
Yeah.
so
We
anyone,
have a lefty knife and a righty.
Louder, because the microphone is not catching.
oh, sure, well, I can talk to the microphone if you want.
Right here.
Oh, that one,
That mic-
okay. So I was asking if there was a curvature on the dimple of the knife, which, I mean, there's one on the right side, so you're saying that there's gonna be one on the left side as well.
There's a righty model and a lefty.
So you have to know beforehand.
You have to buy the one that's appropriate for your hand.
Right.
You just said you realize that you say in European knives, this is unusual. in Asian knives, the way the bevelist cuts it, they're super sharp. You have a righty knife and a lefty knife. So, you know, if you think about it, also you have righty scissors and lefty scissors. So the dimple is meant for the thumb and you grab it properly. But the advantage of the Asian style knife is that it's ambidextrous. It gives you the dimple and it accommodates both righties and lefties.
Thank you. We have a question in the chat. For 3D printing of your knife, what program do you use for modeling?
We started with AutoCAD and then I think Makerspace, no, Shapesworks. Shapesworks is what we're using now. Shapesworks. It just depends on what people have available. You just need something that can read an STL file, so you don't have to start from scratch and can output to an STL file so that you can print it.
Thank you. I think we have a question.
Yeah, that's regular stainless steel. And we cut it with an angle grinder. The discs are basically stone, so it cuts it and also polishes it. Yes.
First is the patent process. Is that something you were familiar with? You did research, you had guidance. How long is that process? And my second question is, in the spirit of continuous improvement, what type of wood? Is it a lighter wood weight in the design of the knife? Is that something you've considered at all?
I wanted wood. Let's start with the patent question.
Okay.
I worked for a patent attorney doing a workflow system, so I was familiar a bit with the patent process beforehand. I worked in the patent office, tracking the process so that we could do it as a computer program. So one of the first software as a service.
From start to end, how long was your shortest patent process to patent a knife?
You can do a design patent in a day. A utility patent, you're going through the text and you have the pictures, that could take a few weeks. Depends on how much time you're willing to invest. And also, patent attorneys are notorious that we're builders. They don't have to have projects in advance, so they don't have downtime. So basically waiting for your term. But the actual process, the guy writes, if you look at it, maybe a week.
Wow. That would be a short experience.
That was a week.
Yeah, but you're waiting for that 4 months to get that root process availability. Got it.
That's about, that depends on the complexity and if you're attorney specialized with it, then you apply for it. And then you have to wait in line again at the USPTO and also Europe. That can be a year and a half just to get into line. Then it goes back and forth and it depends, you know, sometimes you get an examiner that says, wow, yes, you're right. Well, we'll accept that you have to design a utility patent, you have claims. You know, my patent covers this, that, and the other. And he'll say, well, yes, I agree with number one and I agree with number two, but I'm like, oh, the wording for number three. It depends what happens there. That could be also because you're waiting in line, that could be a few months.
Okay.
But they like it, you know. And then depends on the examiner. We had one examiner that just gave us a hatchet job. And we tried to reply to it and give it, and we had a second examiner that said, oh, okay. So there's some luck involved.
Third question, courses that you teach here, is it related to cybersecurity or any of this patent information? Pure, okay. This is your hobby on the side. Okay. And lighter wood, like, have you considered that? The weight?
The wood is a mid-range. But most wood would be light enough for this. It's just a question of getting a high quality wood that looks nice.
Because I want to say all the knives that I've purchased, it's heavier than I would like it to be. I think the lighter ones are the favorites, and the sharper knife, of course, but your design?
We can take a look at how much wood, the effect of the wood on the weight of the knife. That's a good point, because that also influences fatigue and,
Right.
other stuff like that.
Yeah, thank you so much.
Thank you.
Yeah,
Thank you, Norman. We're right at time. I know, Raj, that you have a question. Would you like to ask it now or when we go to lunch and speak with our during lunch? Okay. So with that, first, Norman, thank you so much for a very exciting presentation. We have a gift for you on behalf of the Ignite Hub for being one of our guest speakers. It has some of our Ignite Hub swag in there. You, yes. So enjoy that and thank you so much for your time. This was a very enlightening presentation. I learned a lot, so thank you. For our guests that are here in the space and also virtually online, there is a link and or a QR code that's available to you on your screen. If you wouldn't mind scanning that, this is about your experience and this presentation. We will share it with Norm, and then the Hub team also looks at the information as well of how can we continue to make these types of guest speaker series exciting for you. And if there's another topic you'd like to see or know about, please add that in your survey as well. So thank you. If you can take those just a few minutes to fill that out, we'd appreciate that. And Norman, thank you. We're going to have lunch for our in-person guests right after this. And that's it. So thank you.
thank you for those in Zoom. The link is in the chat. Thank you.